Hello guys, how are you? I hope everybody is able to hear me. So we are in the third day of machine learning live sessions. So this is the third day live on machine learning algorithm. Machine learning algorithms. So we'll go ahead with the agenda. I hope everybody is able to hear me. Deepak Parwal says that I'm here to waste time. Then Deepak, please skip the session and go home, go whatever you are doing, do aram se. Okay, I've never forced anyone to come into this session. Hit like, so then I'll start writing the agenda. Let's cross around 200 likes at least before we start the agenda. So first of all, in the previous session, what all things we discussed? So the first thing that we discussed was linear regression. So how was the experience till 2 sessions, guys? So second one, probably we discussed about ridge and lasso, and the third one was logistic regression. So within 2 days we were able to cover all these things. Okay, so in 2 days we are able to cover these things, which is pretty much amazing because these are some complex algorithms. So if you were able to understand these things, then probably we will be able to understand all the other algorithms in a better way. Okay, now first thing first, what is the agenda of today's session? First of all, we will complete practicals for all the algorithms that we have discussed. These all algorithms that we have discussed, we will cover the practicals. Okay, probably we will be doing hyperparameter tuning, everything. The second thing, and again here we are going to take just simple examples. Okay, so in the future I may come up with 7 days live session on solving machine learning projects. So that is the plan, and that plan will happen on let's see. Okay, because I'm planning that whether we should have EDA first, EDA feature engineering first, and then probably go to the machine learning projects. That I will probably decide. Okay, so yes, so today's session, as said, practicals with simple examples where I'll probably discuss about all the hyperparameter tuning. Then the second one, second algorithm that I'm going to discuss about is something called as naive bias. This is a classification algorithm, so we are going to understand the intuition. And the third one that we are going to probably discuss is KNN algorithm. Okay, so KNN algorithms is definitely there. So this are today's plan. I know I've written very less, but this much maths is involved in naive bias, right? We'll understand the probability theorem again over there. There is something called as bias theorem we'll try to understand, and then we'll try to solve a problem on that. Okay, so let's go ahead. I hope everybody is fit and have all the energy, right? Amrinder, you can basically find all the PDFs in the courses, community courses link. The link is given in the description. And as you all know, okay, subscribe to my Hindi channel, that is Fresh Nayak Hindi. Okay, so please make sure that you also subscribe to that channel because I am actually uploading daily content now over there. It would be a request again to share with your friends who likes to learn in Hindi. So please make sure that you also share this channel to them. I'm giving the link in the chat section so that you will be able to see this. Okay, so here you have to basically subscribe. I've pinned the message. So let's proceed and let's enjoy today's session. How do we enjoy? First of all, we enjoy by creating a practical problem. So I am actually opening a notebook file in front of you. So here we will try to solve it with the help of linear regression, ridge, lasso, and try to solve some problems. Let's see how much we will be able to solve it. But again, the aim is that we learn in a better way. Okay, so that everybody understands some basic things. Okay, so first of all, as usual, everybody open your Jupyter notebook file and just give me a thumbs up so that I start. Okay, just give me a thumbs up. Are we good to start? Then probably I will start doing it. Okay, the first algorithm that I am going to discuss about is something called as sklearn linear regression. So everybody, I hope everybody knows about this sklearn. Let's see what all things are basically there in this. We will be using fit intercept everything as such, but here the main aim is to find out the coefficients, which is basically indicated by theta 0, theta 1 and all. Okay, collab bhi chalega, kuch bhi chalega. It's your wish. I will never stop you. You are a more creative person than me because you learn too much and probably you keep on learning too much. That is what I definitely like in you all, so where you are specifically learning a lot of things. So let's start, and probably let's start writing codes. Let me just make sure that I keep everything ready. Just a second, just give me a second, guys. Max to max 1 minute so that I keep everything ready in front of me. Mm-mm. Okay, so everybody, I hope, is ready and ready to rock. Now, first thing first, here, see, I will not focus more on EDA part and all right now, because EDA will do a 7 days live session. Very nice session we will do, and we will try to complete it. Okay, so let's start. The first thing, we'll start with linear regression, linear regression, and then we will go ahead and discuss with ridge and lasso. Okay, I'm just going to make this as markdown. How many different libraries of for linear regression you can do with stats, you can do with scipy, you can do with many things. Okay, so first thing first, let's first of all we require a data set. So for the data set, what we are going to do is that we are going to basically take up some smaller data. Just let me do this. Just a second. Okay, so for this we are going to take the house pricing data set. So we are going to solve house pricing data set problem, a simple data set which is already present in sklearn only. Now in order to import the data set, I will write a line of code which is like from sklearn dot datasets import load underscore Boston. So we have some Boston house pricing data set. So I'm just going to execute this. I'm also going to make a lot of cells so that I don't have to again go ahead and create all the cells again. Some basic libraries that I probably want is import numpy as np, import pandas as pd, okay, import cbon as sns, and then I will also import matplotlib dot pyplot as plt, and then percentile matplotlib dot inline, and I will try to execute this. See this, my typing speed has become a little bit faster by executing these queries again and again. Okay, and let's go ahead. So I have imported all the necessary libraries that is required, which will be more than sufficient for you all to start with. Okay, now in order to load this particular data set, I will just use this library called as load underscore Boston, and I'm going to just initialize this. So if you press shift tab, you will be able to see that load and return the Boston house prices data set. It is a regression problem, it is saying. Okay, and then probably I'm just going to execute it. Now once I execute it, I will go and probably see the type of df. So it is basically saying sklearn.utils.bunch. Now if I go and probably execute df, you'll be able to see that this will be in the form of key value pairs. Okay, like target is here, data is here. Okay, so data is here, target is here, and probably you'll be able to find out feature names is here. Okay, so we definitely require feature names. we require our target value and our data value. So we really need to combine this specific thing in a proper way in the form of a data frame so that you will be able to see this. Okay. So what I'm actually going to do over here, I'm just going to say pd dot data frame. I'll convert this entirely into a data frame and I will say df dot data. See, this is a key value pair, right? So df dot data is basically giving me all the features value. So if I write df dot data and just execute it, you will be able to see that I will be able to get my entire data set in this way, right? My entire data set in this way. This is my feature 1, feature 2, feature 3, feature 4. This feature 12, I have 12 features over here, and based on that, I have that specific value. Now, the next thing that I am going to do, probably I should also be able to add the target feature name over here, right? So what I will do, I will just convert this into df, okay? And then I will also say df dot columns and I'll set it to df dot target. Okay, and let me change this to data set. So I'm going to change this to data set and I'm going to say data set dot columns is equal to df dot target. So if I execute this and now if I probably print my data set dot head, you will be able to see this specific thing. Okay, it is an error. Let's see, expected axis has 13 element, new values has 506. So target, okay, I should not use target over here. Instead I had a column which was called as feature names. Okay, like if I go and probably see df over here, you'll be able to see there is one thing which is called as feature names. So I'm going to use df dot feature names over here. So here it is, df dot feature names. I'm just going to paste it over here. And now if I go and write, here you can see print df dataset dot head. If I go and execute without print, you will be able to see my entire dataset. So these are my features with respect to different things. I hope everybody is able to understand. Okay. And this is basically a house pricing data set. So initially I have these features: CRIM, ZN, Indus, CHAS, NOx, RM, age, distance, radius, tax, PT ratio, BL stat. Okay. So I have my entire data set over here. The same data set I have basically put it over here. Now here also you will be able to see what all this feature basically means. This is showing weighted distance to 5 Boston Employment Center. RAD basically means index of accessibility to radial highway. Tax basically means full value property tax rate this much. PT rate basically means pupil teacher ratio. I don't know what the hell it means, but it's fine. We have some kind of data over here properly in front of you. Okay. So I hope till here everybody's clear. Can you give me a thumbs up and some number of likes so that I get the Red Bull? Now 700 people are staying, but 300 likes. I want 1000 likes. Pile up. In starting 15 minutes, you should be able to get all the likes, right? This is important. Okay. So I hope everybody's clear till here. Can you give me a thumbs up or just say yes, yes, no, no, something at least? Okay. So that I continue these things. Yeah. Yeah, code and everything I will type it in front of you, but I will give this in the same community link. I will probably save this particular file and give it to you. Okay. So these are my independent features. What are this? These all are my independent features. If you want the features detail, here you can see it, right? Everything. What is CRIM? This basically means per capita crime rate by town, which is important. ZN, it is proportional of residential land zoned for lots over 25,000 square feet. Okay. So this is my DF. I did not do much. I'm just using data frame, df.data, column features name. I'm getting this value. Okay. Very much simple. Now let's go a little bit slowly so that many people will be able to also understand. Okay. Now this is my dataset.head. Now the thing is that I obviously have taken all these particular values, but this is my independent feature. I still have my dependent feature. So what I'm actually going to do, I will create a new feature which is like data set of price. Okay. I'll create my feature name price of the house. And what I will assign this particular value, this value will be assigned with this target value. This target value is basically the the price of the houses, right? It is again in the form of array. So I'm going to take this and put it as a dependent feature. So here you'll be able to see that my price will be my dependent feature. So here I'll basically write df.target. So once I execute it, and now if I probably go and see my dataset.head, you will be able to see features over here, and one more feature is getting added, that is price. Now this price may be, the units may be in millions. Let's see what is the target value. Somewhere target should be here or there. It should be probably in millions, or I cannot see it, but it should be somewhere here. It should have definitely said that it is probably in millions, or okay, but that is not a problem, I think, but mostly it will be in millions. Somewhere I think it should be here. Okay, I cannot see it, but probably if I put more time, I'll be able to understand it. Okay. So over here, what is the thing, main thing? These all are my independent features, and this is my dependent feature, right? So if I'm trying to solve linear regression, I have to divide my independent and dependent features properly. Okay. So till here, I've just written another line of code. Okay. Now let's go to the next step, that is dividing the data set, dividing the, oh my god, dividing the data set into train into, first of all, I'll try to divide into independent and dependent features. I have a new mechanical keyboard, so that is the reason I'm not adjusted to this keyboard, but it will soon get adjusted. I'll be able to adjust it. Okay. So I want my entire features data set divided into independent and dependent features. X I will be using as my independent feature. So I will write data set dot, I will use an ilock which is present in data frames, and understand from which feature to which feature I will be taking as my independent feature to this feature till lstat. So the best way, that basically means that I just need to skip the last feature. In order to skip the last feature, what I'm actually going to do, from all the columns, I will just skip the last column. So this is how you basically do an indexing with respect to just skipping the last feature, and this will basically be my independent features. Okay, and here I will basically say y is equal to dataset dot ilock, and here I just want the last feature, so I will write colon all the records I want. And see, the first term that we are probably writing over here, this basically specifies with respect to records. Here this specifies with respect to columns. From all the columns, I'm taking the last column. Here I will just take the last column, and this will basically be my dependent features. So here I have basically executed. Now if you can go and probably see x.head, here you will be able to find all my independent features. In y.head, you will be able to find a dependent feature. Okay, so till here I hope everybody is clear. Okay, should I hide myself? Now how small I have to make myself? Guys, should I hide myself? I'm happy to hide myself, but people said that do not hide. Should I hide myself? Hmm? Tell me, okay? If I hide myself, you'll not be able to see anything. So, okay. I think this is fine because I'm in the top right, so that none of you will get disturbed. Okay. So till here, everybody is done. Now let's go to the first algorithm, that is called as linear regression. Always remember, whenever I definitely start with linear regression, I'll definitely not go directly with linear regression. Instead, what I will do is that I'll try to go with ridge regression and lasso regression, because there are a lot of options with respect to hyperparameter tuning. Okay, but I will just show you how linear regression is done. So basically you really need to use a lot of libraries, okay, over here, and based on these libraries will try to install, okay. And what are these libraries? These are basically the linear regression library. So here I'm basically going to use two specific thing. One is linear regression library. So I will just use from sklearn dot linear underscore model, okay, import linear regression. Do you need to remember this? The answer is no, because I also do the Google and I try to find out where in sklearn it is present. Okay. So never do, see, never basically take stress of by hearting something. Okay. Don't do that. Google. Khulla choot hai. Just Google. No need to be shy of that. If I also don't know anything, I'll Google. Okay. Okay. So here is my linear regression. So I will try to initialize linear reg is equal to initialize with linear regression, okay. And then here what I'm actually going to do, I'm going to basically apply something called as cross validation. The cross validation is very much important because in cross validation we divide our train and test data in such a way that every combination of the train and test data is basically taken by care, is taken by the model, and whosever accuracy is better, that all entire thing is basically combined. So here what I'm going to do, I'm going to say mean square error is equal to, here I will import one more library, let's say from sklearn dot model selection. I'm going to import cross val score. So cross validation score basically means it is going to do a lot of train and test split. It's something like this. One example I will show it to you here only. So this is what is my epic pen. This also you should keep yourself ready with tools, okay. So what does cross validation basically do? So, cross validation, oops, let me use some other color. What is the other color? Okay, so in cross validation what happens, what you do, suppose this is your entire data set. Suppose this is 100 records. If you do 5 cross validation, then in the first, this will be your test data and remaining all will be your training data. If in the second cross validation, this will be your test data and remaining all will be your test training data. Like this 5 times you'll be doing cross validation by taking the different combination of train and test. But I'm not going to discuss much about it in the future. If you want a separate session, I will include that in one of the session itself. Okay. So this was basically the plan with respect to cross validation or cross val score. So here I'm going to basically take cross val score, and here the first parameter that I give is my model. So linear regression is my model, and here I will take x and y. I'm not doing a train test splits specifically over here. I'm giving the entire x and y, and probably based on that I'm going to do a cross validation over here. You can also do train test split initially and then just give the x train and y train over here to do the cross validation. It is up to you, but the best practices will be that first you do the train test split and then only give the train data over here to do the cross validation. Why I'm doing like that? Because I am right now very lazy. Okay, I want to quickly finish this up because we really need to uncover up a lot of algorithms. Okay, I'm just going to use scoring is equal to, you can use mean squared error, negative mean squared error. Let's say that I'm going to use negative mean squared error. Again, where do you find all these things? You will be able to see in the sklearn page of linear cross val score. Okay, and then finally in the cross val score you give cross validation value as 5, 10, whatever you want. Okay, so till here everybody is clear. Okay, I'm just taking cv is equal to 5. Here you can play with multiple cvs, multiple cv value. Okay, just put a for loop on top of it. That's it. You want to try with multiple cv, go ahead with it. Okay, now the next thing is that after this, uh, I hope everybody is clear till here, right? So after this, what I'm actually going to do, I'm just going to basically from this, how many scores I will get. The mean squared error will be 5 since I'm doing 5 cross validation. If you don't believe me, just see over here, print MSC. So here you'll be able to see 5 different values, 1, 2, 3, 4, 5. right? 5 different mean values because we are doing five cross validation. So here what I'm going to write, I'm just going to say np dot mean. I want to take the average of all the 5. So here will basically be my mean underscore MSE. Okay. And then probably I will print my mean underscore MSE. So this will be my average score with respect to this. The negative value is there because we have used negative mean squared error. But if you just consider mean squared error, then it is only 37.13. Okay. So this I have actually shown you how to do cross validation. See, with respect to linear regression, you can't modify much with the parameter. So that is the reason why specifically in order to overcome overfitting and do the feature selection, we use ridge and lasso regression. So here I will show you how to do ridge regression now. Now, in order to do the prediction, all you have to do is that just go over here, take the model. Okay. What is the model? Linear underscore reg, and just say dot predict. Sorry, MSC dot predict. Okay, just a second. Cross variable linear regression. Sorry, linear underscore reg. So here you can see you will be getting a function called as dot predict, and give the test value whatever you want to predict. Automatically the prediction will be done. Okay. So I'm just going to remove this and focus on ridge regression right now, because I want to show how hyperparameter tuning is done in ridge regression. Okay. So for ridge regression, the simple thing is that I'll be using two different libraries from sklearn dot linear underscore model. I'm going to import ridge. Okay. So for the ridge, it is also present in linear underscore model. For doing the hyperparameter tuning, I will be using from sklearn dot model underscore selection. Okay. And then I'm going to import grid search CV. Okay. So these are the two libraries that I'm actually going to use. Grid search CV will be able to help you out with okay, I will be able to help you out with hyperparameter tuning. Okay. And then probably you'll be able to do that. Difference between MSC and negative MSC, not big thing, guys. If you use MSC here, mean squared error, you'll be getting 37. I've just used negation of MSC. It's okay. Anything is fine. You can go with MSC also. Mean squared error. There is also another scoring area which focuses on root mean square error. Okay, so there are different things which you can basically focus on. Okay. Now, in order to give you this specific good value, I'm actually going to do hyperparameter tuning. So till here, everybody is clear, guys? Can I get a quick yes? Till then, I'll just drink some water. Everybody clear till here? Good. Good. Great. Okay. Yes, Shubham. I think mean squared error is not there, then probably use n negative mean squared error. But you can use different parameters also. Okay. Now let's go ahead with grid search CV. So here what I'm going to do, again, I'm going to basically define my model, which will be ridge. Okay. So this is what I have actually imported. Now let me open the ridge sklearn. So sklearn ridge. We need to understand what all parameters are basically used. Okay. Do you remember this alpha value, guys? Do you remember this alpha value? Why do we use alpha? I told you, alpha multiplied by slope square. If you remember, in ridge, we specifically use this, right? Ridge and lasso regression, alpha. So this is the alpha. This is probably the best parameter we can just perform hyperparameter tuning. The next parameter that we can probably perform is basically this max iteration. Okay, max iteration basically means how many number of iteration, how many number of times we may probably change the theta 1 value to get the right value. Okay, so we can do this. So what I'm actually going to do, I'm going to select some alpha values. I'm going to play with this. Apart from that, if I want, I can also play with the other parameters which are like kind of probably you can also play with the iteration parameter. It is up to you. Try whichever parameter you want to change. You can go ahead and change it. Now let me show you how do we write this and how do we make sure that the specific thing is done. Okay, now before doing grid search CV, let me do one thing. Okay, um, I will define my parameters. Okay, so here is my ridge. Now what I'm going to do, I'm going to say parameters. Okay, and in this parameter, two important value that I'm probably going to take is this one, that is my C value, and I will try to define this in the form of dictionaries. Okay, so here the C value that I, sorry, not C, just a second guys, my mistake, it is not C, it is alpha. Let's see. So how do I define my alpha value? We'll try to see. So here the parameters will be alpha. C is basically for logistic regression. I'll show you. So the alpha value, I will just mention some values like 1 e to the power of minus 15. Okay, that basically means 0.00000000000001. Okay, similarly I can write 1 e to the power of minus 10. That again means 0.00000000 10 times 0 1. Okay, I'm just making fun. Okay, so that you will also get entertained. 1 e to the power of minus 8. Okay, similarly I can write 1 e to the power of minus 3. From this particular value, now I'm increasing this value. See, 1 e to the power of minus 2. Okay, and then probably I can have 1 5 10 20, something like this. So I'm going to play with all these particular parameters for right now, because in grid search CV, what they do is that they take all the combination of this alpha value, and wherever your model performs well, it is going to take that specific parameter and it is going to give you that, okay, this is the best fit parameter that is got selected. Okay, so here I have got all these things. Now what I'm going to do, I'm going to basically apply the grid search CV. Okay, I'm going to basically apply the grid search CV. Okay, so let's go ahead and apply the grid search CV. I know you all people are having fun because I thank myself for taking such an interesting class. I'm kidding. Okay. So here I have ridge grid, I'm saying ridge underscore regressor. So I'm going to use grid search CV, and here I'm basically going to take the parameters ridge. Okay, ridge is my first model, and then I will take up all these params that I have actually defined. See, in grid search CV, if I press shift tab, come on, just a second, I have to first of all execute this, then only it will be able to press shift tab. Okay, so here if I press shift tab, here you will be able to see estimator and parameter grid is my second parameter, then scoring, and then all the other parameters. So here the first thing that goes is your model, then your parameters, which what you are actually playing. Okay, then the third parameter is basically your scoring, and again here I'm going to use negative mean squared error. Some people are saying that mean squared error is not present, so that is the reason why negative mean squared error is done. Why it may not be present? Because they try to always create a generic library. Probably this kind of scoring parameter may also get used in other algorithms. Okay, so that is the reason they may not have created. But if you want to deep dive into it, google karo, pata lagao. Okay, so then what is ridge regressor dot fit on x comma y? Again I'm telling you, you can first of all do train test split on x and y, and then probably only do this on x train and y train. Okay, no need to fight with me. Crush, kyun kar rahe ho x and y? Why not in x train and y train? Do it. Okay, do it in x and y. It's your choice. It's your choice, as usually we say. Okay, parameter is not, oh sorry, Okay, I get this. Okay, parameter is not, and why it is not an? Oh yeah, it has become a list. I'm going to make this as dictionary. Good observation, guys. Right now, I'm fully focused on implementing things. If I get an error, I'll definitely make sure that it will get fixed anyhow. If I get an error, I will not say, "Oh, Krish, why this error came?" You know, why this error came. I'll not get worried. I'll get the error down only. You cannot give this as this one. Okay. So try to understand. Okay. So this is your grid search CV. I've also done the fit. Okay. I've also done the fit over here. And let's go and select the best parameter. So what I can do, I will write print ridge underscore regressor dot params. Sorry, there will be a parameter called as best params. I'm going to print this, and I'm going to print ridge underscore regressor dot best score. So these are all the values that are got selected. One is alpha is equal to 20 and the best score is minus 32. So initially I got minus 37, but because of ridge regression, you can see that our negative mean squared error has definitely become better. There is a minus sign, don't worry, but from 37 it has come to 32. Okay. Cross validation, guys. Over here inside grid search CV also, when it is probably taking the entire combination, over there the CV value cross validation also we can use, right? What you cannot see? After CV, nothing is there, guys. Only CV is equal to 5. इस शैलेंद्र को भी ना. Okay. 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 So probably, if I am probably considering all these things, many people has a question, Krish, is this minus value increased? That basically means you cannot use ridge regression. You are right. In this particular case, ridge regression is not helping you out. Okay. Yes. One guy is basically saying, what about scaling? Very important point. Okay. Very important point. What about scaling? I'm not doing scaling over here because scaling will definitely give a better performance. So guys, let me again write it down. Everybody, don't worry. Yeah, previous I got minus 32. Right now I'm getting minus 37. Right? Sorry, previously I got what? Minus 37. Minus 37. Now I got minus 32. Right? So here you can see this I got it from linear regression. This I got it from what? Ridge. Right? Which one should I select? I should select this model only because it is performing well than this. Okay. But again, understand ridge also tries to reduce the overfitting. Okay. So probably in this particular scenario, we cannot use ridge because the performance is becoming more bad. Okay. So what I will do? I will go and try with lasso regression now. इतना टेंशन क्यों ले रहे हो? It is not necessary that it always increases your performance. Simple, right? If you are not getting, it's okay. टेंशन मत लो. दूसरा करेंगे, lasso से करेंगे. I'll copy and paste the same thing. lasso से कर देंगे. ठीक है? So linear model, import lasso. Okay. Then this will basically be my lasso. Let's see with lasso whether it will increase or not. Lasso. 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 ठीक है? Let's see. This is my parameter that got selected. Now let me write lasso regressor dot best params. So this is alpha is equal to 1 is got selected over here. I'm just going to print it. Okay, and then I'm going to print with lasso regression dot score will be the best score. So here I'm actually getting minus 35. Okay, minus 35. Here I'm actually getting minus 32. So minus 35. Still I will focus on linear regression. Now see what will happen. If I add more parameters, see what will happen. So now I'm going to take alpha different values. See this. I'm just going to remove this and probably add alpha value in this way. See here I have added more values 1, 5, 10, 20, 30, 35, 40, 45, 100. Okay. Let's see whether our performance will increase or not. So here, first of all, let me remove from here in ridge. Just take it down, guys. I'm adding more parameters like this. Okay. Just take it down. Yeah, CV is equal to 5. Nobody. Okay, you're not able to see it. Okay, just a second, everyone. Give me some sunshine, give me some rain, give me little bit time to make you learn everything. La 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 la. Okay. So this is fine now. CV is equal to 5. Okay. Everybody. Okay. Now I think everybody is able to see it. Very good. Very nice. Now here it is. What you can basically focus on. Okay. So here you can see I have added some values like this. You can also add and just try to execute. And now if I go and probably see, this is my see first I have tried for ridge. I'm getting minus 29. Do you see after adding more parameters what happened in ridge? After adding more parameters what happened in ridge? After adding more parameters in ridge, what happened? You can see over here minus 29. Right? And the alpha value that is got selected is 100. If you want, try with cross validation 10 and just try to execute now. So these are some hyperparameters that we will definitely play with. Here you can see minus 29. Okay. So here you can see minus 29. You can also increase the cross validation value over here also and probably execute it. But with lasso, I don't know whether it is improving or not. It is coming to minus 34. Okay. Everybody clear with this? समझ में आया कि नहीं everyone? You just have to play with these parameters. As now for a bigger problem statement, the thing is not limited to here, right? We try to take multiples and many parameters. Okay. Multiples and many parameters and try to do these things. Okay. It is up to you. It is up to you. We play with multiple parameters. Whichever gives us the best result, we are basically taking it. It's okay. Error is increased. I know that. No. Error is increasing. Definitely error is increasing. Even though by trying with different parameters. But most of the scenario, See here, I got minus 37. Probably what I can actually do is that try to get better one with respect to this. Chalo. Now the best way, what I can also do is that I can basically take up train and test split also. Okay, and probably do these things. Let's see one example. Okay, so how do we do train and test? From sklearn dot, I think model selection, import train test split. Okay, it's okay guys, you may get a different value. Okay, okay, let's do one thing. Okay, let's make your problem statement little bit simpler. Now what I'm going to do, just tell me in train test split what we need to do. So I'm going to take the same code, I'm going to paste it over here. Okay, or let me do one thing, let me insert a cell below and let me do it for train test split. Okay, okay, so in train test split what we can do, just tell me with respect to train test split. No fun in doing practicals, guys? I hope you're not loving this, or what is the problem? Like fun, right? Otherwise, if you want only theory, then I can do that. It's up to you. So I will just use train test split. Just let me know whether you want theory or not. I think it is simple, right? I'm doing my level best to teach you well. I don't know why people are saying that. I think only some people are saying, not everyone. So I'm just going to take the syntax, paste it over here. Let's say that I'm taking X train, Y train, and then I'm using train test split with 33%, right? Understand? Now here people are saying, sir, it was minus 37. I got minus 21. This value should go towards 0, no? Yeah? या theory तो कल हो गया ना? Okay, I can't, what I can say, forget, let it be now. Now if I execute with respect to X train and Y train, so here is my, you can see this, I've written this code from sklearn.model selection. Okay, train test split, random state can be anything, whatever you write, it is fine. Then you basically give X and Y with test sizes 0.33. This is basically saying that the test will have 33% and the train data will be 77%. Okay, so this is what I'm actually getting with respect to X train and Y train. Here, what I'm going to do, I'm going to basically take X train from a Y train. Okay, and now if I go and probably see this, here you can see minus 25. Understand, this value should go towards 0. If it is going towards 0, that basically means the performance is better. Okay, now similarly I do it for ridge. In ridge, what I'm actually going to do here, I'm going to write X train and Y train. Okay, and if I go and probably select the best scores and this, here you will be able to see I'm getting, how much I'm getting, minus 25.47. Okay, here I'm getting 25.18, here 25.47. That basically means now still the improvement is little bit bad, because here we are not going towards 0. Okay, so the next part, again here also you can basically do it for X train and Y train. X train and Y train. So here you have this one, and let's go and execute this. So here you can see minus 25.47. Now what you can also do is that you can use this lasso regressor dot predict, and you can basically predict with respect to x test. So this is your y test value. Suppose let's say that this is my y pred, y underscore pred. Okay. Then what I can do from sklearn, I will be using r square and adjusted r square. If you remember sklearn r square, r square. So this is my R2 score. So where it is present in sklearn.metrics. So I'm going to write from sklearn import let's say I'm saying from sklearn.metrics import r square, R2 score. Now what I'm going to do over here, I'm basically going to say my R2 score, which is my variable. I'll say this is nothing but R2 score. Here I'm just going to give my y pred comma y underscore test. So if I go and probably see the output here, I will be able to see print R2 score. This is all I have discussed, guys. See, if you have not attended the theory, that is not my problem. So I'm getting 0.67. Okay. So if you have not attended the theory, I can't help you. See, there is also adjusted rand score is there. Where is R2? R2 score 1. Let's see. Adjusted R square. Okay, R2 score is there, but adjusted R square should be here somewhere in some manner. Okay. So this is how your output looks like with respect to by using this lasso regressor. Okay, which is very good. Okay, it should be, I told it should be near 100%. Right now I'm getting 67%. If I want to try with ridge, you can also try that. So you can say ridge regressor dot predict, and here you can see 68%. Then you can also try linear regressor and predict. What is the error saying the linear regression is not fitted yet? Why it is not fitted? Why it is not fitted? Oh yeah. Uh-huh. Let's say that I have fitted here linear regressor dot fit on x train and y train, x train and comma y train. So I'm just going to fit it. Now if I go and probably try to do the calculation, so if I go and see my R2 score, it is also coming somewhere around 68%, 67%. Okay. Now since this is just a linear regression, you won't be able to get 100% because you are drawing a straight line, right? So for that, you basically have to use other algorithms like XGBoost and all, Nape bias. So many algorithms are there. So clear, guys, with this three. Now let's go ahead and discuss about logistic. Or should I continue theory or practical? Should I move to Nape bias? Probably logistic we can do tomorrow. You just tell me, okay? I'll just wait for your answer. It's okay. See, you give y test over here, y pred over here, both are same, right? They're comparing. Bhai, see, at one limit you can increase the performance. After that, you cannot. See, again, I'm telling you, in linear regression, what we do, these are my points, right? I will be only able to create one best fit line. I cannot create a curve line, right, over here. So obviously my accuracy will be only limited, is limited, right? So many people are saying logistic practical. Okay. Okay. Let's go and do it logistic practical quickly. And here in logistic also we can do grid search CV. Now what I'm actually going to do, first of all, let's go ahead with the data set. We'll quickly do it, okay? In another 10 minutes, we'll finish it off. So I know guys, see, the thing is that I know many people will say that Krish, कुछ समझ में नहीं आ रहा है, Krish execute कैसे करे? If you have not attended the previous session, okay, then you will not be able to understand what I'm doing over here. See, everything that we have probably discussed in our theoretical class, everything we have implemented over here. Now it's all about practice. How do you practice over there? Okay. Naive Bayes will take at least 30 minutes to explain. Okay. So I will quickly implement logistic. That only I'm telling you guys. See, the thing is that I'm giving my 100% to teach you everything. Okay. If you don't come to the previous class, that is not my mistake. Okay. So from lessKlearn.linear underscore model, I'm going to import logistic regression. So I'm going to use logistic regression, and apart from that, we know that let's take a new data set, because for logistic we need to solve using classification problem. Okay. So this is basically my logistic regression. I'll take one data set. So from sklearn dot datasets import, we'll take a data set which is like breast cancer data set. So that is also present in sklearn. Okay. So with respect to the breast cancer data set, I'm just going to use this. See, load best answer data set. I'm loading it, and all the independent features are in data, and my columns are feature names. The same thing like how we did previously. Okay. So this will basically be my complete independent feature. So if I go and probably see this x dot head, here you will be able to see that based on this input features or independent feature, we need to determine whether the person is having cancer or not. Okay. These are some of the features over here, and this is like many features are actually present. So everybody is done till here. Quickly just tell me quickly and try to do it. Okay, quickly do it in front of me. Write the code over here. Okay, so we will continue the next part over here. After this, what we have to do, आ रहा हूँ नेप बाइज भी पढ़ाऊंगा, सब पढ़ाऊंगा, don't worry. So next thing, that was my independent feature. Now I'll take my dependent feature. Dependent feature will already present in df.target. Okay, this particular data set that we have taken in df. In df.target, we will basically have all our dependent features. These are my independent features, right? So what I'm actually going to do, I'm going to create y, and I'm going to say pd dot data frame, and here I'm going to say df.target target, and this column name should be target, right? So this will be my column name, and now if I go and see my y is basically having zeros and 1 in the target feature. So write this down code. Later on, all the simple things are there. Clear, everybody? Did you explain mathematical part, Digesh? Yesterday I have explained mathematical part. Today, first of all, we are doing practical, and then we'll move to theory. Okay. Now the next thing that we are going to do is that apply the what we have to do. What do you have to do? First of all, we need to check whether this data set is this particular y column is balanced or imbalanced. Okay. In order to do that, I will just write f target. If the data set is imbalanced, definitely we need to work on that and try to perform upsampling. So if I write y target dot value underscore counts, okay, if I execute this, so here you will be able to see that value underscore counts will basically give that how many number of ones are and how many number of zeros are. So now total number of ones are 357 and total number of zeros are 212. So is this a imbalanced data set, guys? Quickly tell me. Is this a imbalanced data set? Is this a imbalanced data set, everyone? Tell me yes or no. Then probably this is a balanced data set, right? So here I'm actually going to now do train test split. Okay, train test split I will try to do. Again, train test split, how do we do? We can quickly do copy the same thing entirely. Okay, I'll copy this entirely over here and then I will get my x and y. So here is my x train, x test, y train, y test. So train test split, obviously I'll be doing it. Now in logistic regression, if I go and search for logistic regression sklearn, I will be able to see this, what all parameters are there. Can anybody tell me what is this L2, L1? This is basically the L1 norm or L2 norm or L1 regularization or L2 regularization. Okay, with respect to whatever things we have discussed in logistic. Okay, and then the C value, these two parameter values are very much important. If I probably show you over here, the penalty, what kind of penalty, whether you want to add a L2 penalty, L1 penalty, you can use L2 or L1. The next thing is C. This is nothing but inverse of regularization strength. Okay, this basically says 1 by lambda, something like that. Okay, so this, how to do upsampling, I've already made a separate video on that, you can check it out. Okay, uh, this parameter is also very much important, guys. Class weight. Suppose if your data set is not balanced, at that point of time you can apply weights to your classes. Okay, if probably your data set is balanced, you can directly use class weight is equal to balanced. Okay, other than that you can use other weights which you basically want. Okay, so this is specifically some of this, right? No, this is not ridge or lasso. Okay, this is logistic. In logistic also you have L1 norm and L2 norms. Understand, probably I missed that particular part in the theory, but here also you have an L2 penalty norm and L1 penalty norm. Okay, understand this thing. I probably did not teach you in theory, because if you look, see, logistic regression can be learned by two different ways. One is through probabilistic method and one is through geometric method. Probabilistic method I taught you yesterday. If you go and probably see the, if you go and probably see my video that is present with respect to logistic regression right now in my YouTube channel, there I have explained you about this L1 and L2 norms also over there. Okay, so in this also it is basically present. It is a kind of penalty, again, just for using for this kind of classification problem. Okay, so what I am actually going to do, let's go and play with the parameters that I am looking at. So I will play with two parameters. One is params C value. Here I'm defining 1, 5, 10, 20, anything that you can define, one set of values you can define. And there was one more parameter which is called as max iteration. This is specifically for grid search CV. Okay, that I'm specifically going to apply. Okay, so I will just try to execute this. Okay, this will be my params. Now I'm going to quickly define my model 1, which will be my logistic regression model. So my logistic regression here, by default, one value I'll give for C and max iter. Let's say I'm giving this value. Later on, what I will do for this model, I'll apply it to grid search CV. So I'm just going to say grid search CV and I'm going to apply it for model 1. Param grid is equal to params. Okay, this parameter that I'm specifically trying to apply. Since this is a classification problem and I am not pretty sure that whether true positive is important or true negative is important, I'm going to use F1 scoring. Okay, F1 scoring is basically again the parametric term which we discussed yesterday, which is nothing but performance metrics. And then I'm going to use CV is equal to 5. So this will be entirely my model with respect to grid search CV and I'll be executing this. Then I will do model.fit on my X train and Y train data. So once I execute it, here you can see all the output along with warnings. A lot of warnings will be coming. I don't know, because this many parameters are there. And finally, you can see that this has got selected. Okay. Now, if you really want to find out what is your best param score, model dot best params. So here you can see max iteration as 150, and what you can actually do with respect to your best score, model dot best score is 95 percentage. But still we want to test it with test data. So can we do it? Yes, we can definitely do it. I'll say model dot score, or I'll say model dot predict on my X test data, and this will basically be my Y pred, right? So this will be my Y pred, all the Y prediction that I'm actually getting. So if you go and see Y pred, so these are my ones and zeros with respect to the Y prediction. And finally, after getting the prediction values, I can apply confusion matrix. I hope I have taught you about confusion matrix. So from sklearn dot confusion matrix, sorry, sklearn dot matrix, I'm going to import confusion matrix, classification report, and the next thing that I would like to do is this two. I will try to import confusion matrix and classification report. Okay. Now, if you want to see the confusion matrix with respect to your, I can just write y underscore pred or y underscore test, whatever you want, go ahead with it. And this is basically my confusion matrix. If I put this forward, no difference will be there. Only this thing will be moving. Okay. That also I showed you 63, 118, 3 and 4. Okay. Now, finally, if I want a accuracy score, I can also import accuracy score over here. Okay. So here you can see accuracy score is imported. I can also find out my accuracy score, which is the total accuracy with respect to this. We can give y test and y underscore pred, which we have discussed yesterday. This is giving 96%. If you want detailed precision recall all the score, then at that point of time I can use this classification report, and here I can give y test and y pred. Here is what I'm actually getting. So here you can see with respect to F1 score, precision recall, since this is a balanced data set, obviously the performance will be best. Okay. Everybody clear? Yes, you can also use ROC. See, I'll also show you how to use ROC, and probably you'll be able to see this. You have to probably calculate false positive rate, true positive rate, but don't worry about ROC. I will first of all explain you the theoretical part. Yesterday we discussed about precision recall, F1 score, confusion matrix, classification report, everything, right? So I'm teaching you this. In the next class, I will try to show you about ROC. Okay. So don't worry, this entire materials I will be adding it in the community live sessions over there. All the resources will be available to you. Okay, so you don't have to worry. Now let's go ahead and discuss about naive Bayes. Naive Bayes is an important algorithm. So here I'm just going to go ahead. Okay, did you like the session? Okay, did you like the session or not? Hit like. Classification report will be giving you precision recall F1 score. Yesterday we discussed about precision everything, right? Thank you, Digesh Patel. Classification report basically means precision recall and F1 score. Okay. So shall I continue now and discuss about naive Bayes? ROC, AUC, I will discuss it. Don't worry. So now let's go ahead and discuss about naive Bayes. And here we are going to discuss about the intuition. Okay. Ray. What is log loss? Log loss, yesterday only I have told about the cost function of logistic regression. It has log loss, right? Okay. So naive Bayes is another amazing algorithm which is specifically used for classification, and this specifically works on something called as Bayes theorem. Now, what exactly is Bayes theorem? First of all, we need to understand about Bayes theorem. Okay. So Bayes theorem will try to understand and basically understand all these things. Okay. So with respect to Bayes theorem, we'll try to understand what all things we need to discuss. Okay. So let's go ahead and let's talk about this Bayes theorem. Let's say that, guys, I have Bayes theorem. Let's say that I have an experiment which is called as rolling a dice. Now in rolling a dice, how many number of elements I have? Okay. So if I say what is the probability of 1, can anybody tell me? What is the probability of 1? What is the probability of 1 coming in this when I roll a dice? Then obviously you'll be saying 1 by 6. If I say probability of 2, then also here you'll say 1 by 6. If I say probability of 3, then I will definitely say it is 1 by 6. So here you know that this kind of events are basically called as independent events, right? We discussed this in probability. Independent events. If you have attended my 7 days live session on stats, you have understood that this is basically independent events. Okay. Now rolling a dice, why it is called as an independent event? Because getting 1 or 2 in every experiment, 1 is not dependent on 2, 2 is not dependent on 3. Okay. So they are all independent, right? So that is the reason why we specifically say is an independent event. But if I take an example of dependent events, okay, if I probably take an example of dependent events, let's say what is a dependent event? Okay, let's consider that I have a bag of marbles. Okay, in this marble I basically have 3 red marbles and I have 2 green marbles. Okay, now tell me what is the probability of, suppose I have an event. In the first event I take out a red marble, so what is the probability of taking out a red marble? So here you can definitely say that it is 3 by 5. Okay, so this is my first event. Okay, now in the second event, let's say that in this you have taken out the red marble. Okay, now what is the second time again you are taking out the second red marble, or forget about second red marble. Now you want to take out the green marble. Now what is the probability with respect to taking out a green marble? So here you will be definitely saying that, okay, one red marble has been removed, then the total number of marbles that are left are 4, right? So here you can definitely write that probability of getting a green marble is nothing but 2 by 4, which is nothing but 1 by 2. I hope everybody is agreeing. Yes, everybody is agreeing over here, right? So here what is happening? First element you took out, first marble that you took out, first event from the first event you took out red marble, from the second event you took out green marble. These two are dependent events because the number of marbles are getting reduced as you take out from them, right? So if I tell you what is the probability of taking out a red marble and then a green marble, so it's the formula will be very much simple, right? Which we have already discussed in stats. It is nothing but probability of red multiplied by probability of green given red, right? So this specific thing is called as conditional probability. This specific thing is called as conditional probability. Okay, this is specifically called as conditional probability, this one. Here understand what is happening. Probability of green marble given the red marble event has occurred. Okay, here both the events are independent. Okay, now let me write it down very nicely. So I can write probability of A and B is equal to probability of A multiplied by probability of B divided by probability of A. Okay, now let's go and derive something. Can I write probability of A and B is equal to probability of B and A? Can I write like this? Can I write this too? Same? Is this fine or not? This statement is fine or not? Very much clear. Can I write probability of A and B is equal to probability of B and A? So this is my specific question. Okay. So our answer is yes. We can definitely say. Yes. We can definitely say. If you go and do the calculation, you'll be able to get the answer. You should not say no. Both are same. Okay. Don't say no. Just don't say no. Why everybody is saying no? Both are same. You do the event, guys. You do this. Okay. You do this calculation. Probability of red and green is equal to probability of green and red. So the answer is yes. Now again people are saying no. No, it is yes. Okay. I can definitely write like this. Okay. Now what is the formula for probability of A and B? So here you can basically write probability of A multiplied by probability of B given A. Okay. Oh my god. Okay, fine. Now tell me, if I take out probability of green, what is probability of green in this particular case? 2 by 5. What is probability of red over here if green is removed? 3 by 4. What is the answer? Just see this. Just see this, guys. Verify it, okay? I don't want to waste time. Let's see. If you don't get it, just let me know. Okay? Just let me know. Okay. For right now, let's consider this. Now, this part I can definitely write as probability of B multiplied by probability of B, this one probability of B, and this will be probability of A given B. Okay. So I can definitely write this much with respect to all this information. Now, can I derive probability of A is equal to probability of B multiplied by probability of A divided by B, means probability of A given B divided by probability of what this will become? Sorry, I'll write this as probability of B given A divided by probability of A. Can I write this one? Is this true? Yes. And this is specifically called as Bayes theorem. Okay. And this is the crux behind naive Bayes. Okay. This is the crux behind naive Bayes. I hope everybody is able to understand it. Okay. The crux, the entire theorem that is specifically getting used is this. Okay. So understand, this is the crux behind the Bayes theorem. Now let's go ahead and let's discuss about how we are using this to solve. Okay. How we are using this to solve. Let's take some examples and probably make you understand. Okay. Let's say that I have some features like x1, x2, x3, x4, x5, like this till xn, and I have my output y. Okay. So these are my independent features. These all are my independent features. These all are my independent features. So here I'm going to write independent features. And this is my output feature, which is also my dependent feature. Right? Again, one guy is saying go. No, go crux. Okay. Now what is happening? If I say probability of B or A, what does this basically mean? I need to really find what is the probability of Y. And you know that, right, guys, I will have some values over here. and basically I will have some output value over here. So based on this input values, I need to predict what is the output. Initially on a training data set, I will have your input and then your output. Initially my model will get trained on this. Okay. Now let's consider what this entire terminologies I will try to write in terms of this equation. So I will say probability of y given x1, x2, x3 up till xn. Then this equation will become probability of y. See, probability of y given x1, x2, x3, xn. This a is nothing but x1, x2, x3, xn. And I am trying to find out what is the probability of y. Okay. And then I will write probability of b. B is nothing but y. But before that, what I will write? Probability of a divided by b. Right? A given b. Or probability of b. Probability of b is nothing but y. Right? Multiplied by probability of a given b. Probability of a given b basically means probability of x1, x2, xn given b. B is given, right? So I am able to find this entire value. Right? Everybody is clear with respect to this? No, just a second. I made some mistakes, I guess. Probability of a. No. Just a second. There is a small mistake. I will just confirm it from my notes. Just give me a second, guys. I think the equation will change a little bit. Just a second. Okay. Now it is correct. Sorry, I just missed one term. That is this given y. Okay. This is how it will become. And this will be equal to probability of a. That is x1, x2 like this up to xn. Now I hope everybody is clear with this. Can I write like this? Yes. Okay. So probability of y multiplied by probability of a given y. Something like this. Okay. Now if I try to expand this, then this will basically become something like this. See what this will become. Just think over it. Just think. If I try to expand this, how this will probably become. How this will probably become. Can I write something like this? Probability of y multiplied by probability of x1 given yes, given y. Sorry, given y multiplied by probability of x2 given y, probability of x3 given y, and like this it will be probability of xn given y. Okay, so this will also be y1, y2, y3, yn. This I can expand it like this, and then this will basically become probability of x1 multiplied by probability of x2 multiplied by probability of x3 like this up to probability of xn. Clear? I hope everybody is clear. Right? So this is with respect to all the probabilities. Right? Very simple till here. I guess anybody will be able to understand. Y will be different, right? Y will be different. See here, for this particular record y will be different, for this y will be different, for this y will be different. Okay, y will be different, no? For x1 y may be different, for x2 y may be different, for x3 y may be different, right? But y output, it may be yes or no, right? It may be yes or no. Okay, I'll solve a problem. It will make everything understand. Okay, and this will probably be probability of y. It can be binary, multi-class, whatever things you want. I'll solve a problem in front of you. Now, the next thing what we can basically do is that with respect to this, I hope everybody understood this much and you're able to understand with respect to this much, right? Now, let's say that I have my y as, let's say that I have a lot of features, x1, x2, x3, x, x4, okay? With respect to this, let's say in my one of my data set, I have this many x1s, this many features, and this is my y, okay? So these are my feature number and this is my y. Let's say that in y I have yes or no, okay? So how I will probably write? We really need to understand this, okay? I will basically say, what is the probability of y is equal to yes given this x of i's. X of i's basically means x of I. This is my first record of x of i's, okay? This is my second record of x of i's. So I may write like this: what is the probability of y being yes if x of I is given to you? X of I basically means x1, x2, x3, x4, okay? So here you'll obviously write what kind of equation? You'll basically say probability of yes multiplied by probability of yes multiplied by probability of x of 1 given yes multiplied by probability of x2 given yes, probability of x3 given yes, and probability of x4 given yes, right? You'll basically write like this: divided by probability of x1 multiplied by probability of x2 multiplied by probability of x3 multiplied by probability of x4, right? This is clear. This I hope everybody is able to understand. We are able to write like this, right? So y is fixed. It may be yes or it may be no, but with respect to different records, this value may change, okay? Similarly, if I write probability of y is equal to no given x of I, what it will be? Then it will be probability of no multiplied by probability of x1 given no, then probability of x2 given no, probability of x3 given no, and probability of x4 given no, right? So here, because any input that I give, any input x of I that I give, I may either get yes or no. So I need to find both the probability, right? So probability of x1 multiplied by probability of x2 multiplied by probability of x3 multiplied by probability of x4, right? See, with respect to any x of I, the output can be yes or no, and I really need to find out the probability. So both the formula is written over here. What is the probability of with respect to yes, and what is the probability with respect to no? Okay. Now in this case, one common thing you see that this denominator is fixed. This is definitely fixed, right? It is fixed. It is not going to change for both of them. And I can consider that this is a constant. This is a constant for a specific problem. So what I can do? I can definitely ignore. Okay. I can definitely ignore. Okay. So here I can definitely ignore these things. Ignore this also, ignore this also. Right? Because see, this is constant. So I don't want to consider this. In the next time, I'll just use this specific formula to calculate the probability. Now let's say that if my first probability for a specific data set, yes, of x of I is, let's say that I'm getting as 0.13. And similarly, probability of no with respect to x of I, if I get 0.05. You know that in a binary classification, any values, if we get greater than or equal to 5, we are going to consider it as 1. And if it is less than 0.5, I'm going to consider it as 0. Now, I'm getting values like this 0.13 and 0.05. Tell me whether it should be 1 or 0. Tell me whether this should be 1 or 0, or which one should be the output in this particular scenario. Whether it should be 1 or 0, the output. Obviously, I'm getting 0.13, 0.05. So we do something called as normalization. Okay, we will do something called as normalization. What is normalization basically saying? It says that if I really want to find out the probability of x with x of I, if I do normalization, it is nothing but 0.13 divided by 0.13 plus 0.05. Now tell me how much this is if I open a calculator. Okay, if I open a calculator, so this is 0.13 divided by what it is 0.13 plus 0.05. It is 0.18. So if I 0.13 divided by 0.18. So if I go and see, it is nothing but 72.72. 0.72. This is nothing but 72 percentage. And similarly, if I do for probability of no given x of I, here obviously you will say 1 minus 0.72, which will be your remaining answer, that is 0.28, which is nothing but 28%. So your final answer will be this one. Right? So this will, Vikranti, you can leave if you don't want to attend the lesson, because I have kept a target to complete something in 7 days. Okay. Guys, isn't the session becoming interesting, or are you feeling bored? Are you feeling bored? You see, this all you'll not be even able to get properly in textbooks, guys. I refer to many textbooks, but these all things you'll not be able to understand in textbooks. Please look at the efforts that I'm putting, okay, and please become serious in the sessions. I know whether your life how it will become, I don't know, okay, but I'm at least trying to make sure that you will be able to answer most of the questions in interviews and all. Okay, so okay, so I hope everybody has understood this one now. This formulas you have to remember. Now we'll solve a problem. Okay, let's solve a problem. This will be a very, very interesting problem. Let's say that I have a data set. So this is my data set. We'll solve a problem and then we'll try to see that what all things we can actually get. Okay. Let's say I have a data set which has like this feature day. Let me just copy this data set. Okay. For you all. Just a second. I'm going to copy this data set from one of my materials. Let's see. This is a famous data set. I will just try to copy it and put it over here so that I don't put a lot of efforts. So this is my data set. Okay. Everybody is able to see this data set. Just let me know. If you want to write it down, just write it down if possible. Anyhow, I will be giving you this all things. Okay. Everybody take this data set and I'll try to show you how you can basically solve all these problems, guys. I am going to see, I am here. Trust me on my teaching. If you know this much, you will be able to clear your interviews. Okay. Later on, but if you don't want to try it out, it's fine. It's your life. Who am I to stop it? I've zoomed in, guys. I probably zoomed the best I could. Okay. हाँ भाई, रुकेगा नहीं, मैं झुकेगा नहीं, मैं पढ़ा के रहेगा सबको डेटा साइंस. Okay. Okay, fine. Now let's go ahead and let's try to see what this data set basically specifies. Okay. I hope everybody is able to see this data set. Yeah. Now in this data set, I want to take out some information. Let's take out Outlook table. Now based on this outlook feature, see over here outlook, my day outlook, temperature, humidity, wind are the input features, independent feature. This is my output feature. This one that you are probably seeing, play tennis, is my output feature, which is specifically a binary classification. So what I'm actually going to do, I'm basically going to take my outlook feature, and based on this outlook feature, I will just try to create a smaller table which will give some information. Okay. Now based on outlook, first of all, try to find out how many categories are there. In outlook, one is sunny, one is overcast, and one is rain, right? 3 categories are there. So I'm going to write it down over here: sunny, overcast, and rain. So these 3 are my features with respect to sunny. With outlook, I have 3 categories: one is sunny, one is overcast, and one is rain. Here I'm going to basically say, with respect to sunny, how many yes are there and how many no are there, and what is the probability of yes and probability of no. Okay, we are going to calculate this. I hope everybody is clear till here. Again, just a second, I will just write it down a little bit. Again, my face will become coming in between. Okay, just a second. I'm going to again write it over here. So this is my outlook feature, and then I have categories. First, yes, no, okay, sunny, overcast, rain. Yes, no, then probability of yes and probability of no. Okay, so everybody clear with this? Now everybody is, I hope, clear with this. Now the next thing that we need to find out is that with respect to sunny, how many of them are yes? See, yes we have. So when we have sunny over here, the answer is no. So I will increase the count over here, 1. Then again I have sunny, again the answer is no. So I'm going to increase the count to 2. Okay. With this sunny, this is basically no. Okay. So again I'm going to increase the count to 3. Now with sunny, how many of them are yes? 1 and 2. So I have this one and this one. So I have 2. So I'm going to say with respect to sunny, I have 2 yes. Understand, outlook is my x1 or x1 feature. Let's consider. Now the next thing is that, let's see with respect to overcast. With overcast, how many of them are yes? So this overcast is there, yes, 1, 2, 3 and 4. So total 4 yes are there with respect to overcast. Okay. Then with respect to overcast, how many are on no? You can go and find out. It is basically 0 no's. Then with respect to rain, how many of them are yes? So here you can see with respect to 1 rain, yes, yes, no, no. So this is nothing but 3, 2. Just try to find out there are 3's, 2 or not. 1, here also 1 yes is there, right? So 3 yes, 2 no's. So the total number of yes and no's, if you count it, there are 9 yes and 5 no's. This is my total count. Okay, very simple. So if you totally count this, 9 plus 5 is 14. You will be able to compare that. There will be 9 yes and 5 no's. Now what is the probability of yes? Now in order to find out the probability of yes when sunny is given. So suppose if I want to calculate this, what is the probability of yes when sunny is given? I'm just going to write it down. Probability of yes when sunny is given. So here you have 2 by 9. Can I say 2 by 9? Here you have 4 by 9. Here you have 3 by 9. 3 by 9. Now if I say what is the probability of no given sunny? Okay, given sunny. Now see, probability of yes given sunny, probability of yes given forecast, probability of yes given rain. So it is basically that I will just try to write it in a simpler manner so that you will not get confused. Okay, so this is my probability of yes and this is my probability of no. Okay, but understand, what does this basically mean? This terminology basically means probability of yes given sunny, probability of yes given overcast, probability of yes given rain, right? Similarly, what is probability of no? Probability of no, obviously you know that 3 by 5 is my first probability. Then you have 0 by 5 and then you have 2 by 5. Is everybody clear till here? Very simple. I hope you are able to learn it in a very beautiful way. Okay. Now with respect to the next feature, let's consider that I'm going to consider one more feature, and in this feature I will say let's consider temperature. Okay, let's consider temperature. Now in temperature, how many features I have or how many categories I have? I have hot, you can see hot, mild and cold. Okay, so I have hot, mild and cold. Let me write it down properly again. I have hot, mild and cold. Okay. Now with respect to hot, mild, cold, here also I will be having yes, no, probability of yes and probability of no. Now try to find out with respect to hot, how many are yes. So here no is there, here also no is there. Two no's, one yes, two yes. So two yes and two no's probably. Let me compare also with my notebook. Okay. So two yes and two no's. So if you try to find out, there will be two yes and two no's. Okay. Then similarly with respect to mild, how many are there? One yes, one no, two yes, three yes, four yes and two no's. Okay. So here you basically go and calculate four yes and two no's. With respect to cold, how many are there? Cool or cold. One yes, one no, two yes, three yes and one no, right? So here I have specifically have 3 yes and 1 no. Again the total number is 9 and 5, which will be equal to the same thing that what we have got. Now really go ahead with finding probability of yes given hot. So it will be 2 by 9 over here. Then here it will be how much? 4 by 9. Here it will be 3 by 9 again. Here what will be the probability of no given hot? So it will be 2 by 5, 2 by 5, 1 by 5. Okay, so these two tables has already been created. Okay, very simple. Everybody is able to understand in a better way. Appreciate, guys. Come on. I need energy. Come on. I require energy. For that, you need to give me likes. You need to tell me, Krish, बहुत ही बढ़िया पढ़ा रहे हो. And finally, with respect to play, the total number of plays are yes is 9, no is 5, and the answer is total 14. If I say what is the probability of yes, only yes, then it is nothing but 9 by 14. What is the probability of no? It is nothing but 5 by 14. Okay, so these two values also you require. Now let's say that you get a new data set. You need to get a new data set. Let's say you get a new test data where it says that suppose if you are having sunny and hot, tell me what is the output. So this is my problem statement. Right? So what is my output in this particular case? So let me write it down. So here I will write probability of yes given sunny comma hot. Right? So this should be my equation. Right? Then here I will write probability of yes multiplied by probability of क्या बोलना चाहिए इसमें? चलो इक्वेशन देखते हैं फिर से. Probability of x1, probability of sunny given yes. क्या लिखना चाहिए बताइए? Okay, so here I will write probability of sunny given yes multiplied by probability of hot given yes divided by what is it? Probability of sunny multiplied by probability of hot. ये रहा आपका इक्वेशन और ये पूरा का पूरा कैंसिल हो जाएगा. क्यों कैंसिल हो जाएगा? बिकॉज इट इज अ कांस्टेंट. because probability of no also I will be getting the same value. Okay. Now, what is probability of yes? You know what is the probability of yes, right? We calculated here. What it is? 9 by 14. Probability of yes is how much? 9 by 14. See over here, 9 by 14. So, probability of yes, I am going to replace it with 9 by 14. Multiplied by, क्या आना चाहिए? Probability of sunny given yes. Probability of yes, sunny given yes कितना है? 2 by 9. Probability of sunny given yes, 2 by 9. Right? So, I am going to basically write 2 by 9. Then probability of hot given yes क्या है? मैं जाऊंगा दूसरे टेबल में. Probability of hot given yes is nothing but 2 by 9. So I am going to get 2 by 9. So यहाँ हमारा हो जाएगा 9 9 cancel और ये हो जाएगा 2 1 7 then this is nothing but 2 by 63 which is equal to 0.031. I hope so I am right. भगवान करे राइट, नहीं तो सब लोग मुझे मारेंगे. 2 divided by 63. Yeah, I am absolutely right. I read this statement little bit wrong. It should be probability of sunny given yes. Okay, probability of sunny given yes. No, Vasco Rao, again I am saying this statement is nothing but probability of sunny given yes. Okay, I read it in a wrong manner before. Okay, this should be like this, probability of sunny given yes. Okay, that was the minor thing. Now go ahead and calculate what is probability of no given sunny and hot. Quickly tell me. So here you have probability of no multiplied by probability of sunny given no multiplied by probability of hot given no divided by probability of sunny multiplied by probability of hot. This will get cancelled. Denominator is a constant, guys. This is a constant. Okay. So what is probability of no? So probability of no is nothing but 5 by 14. So I will write over here 5 by 14 multiplied by probability of sunny given no. What is probability of sunny given no? What is probability of sunny given no is nothing but probability of sunny given no is nothing but 3 by 5. 3 by 5, right? This is what it is. So this is 3 by 5. So here I am going to get 3 by 5 multiplied by probability of hot given no. It is nothing but 2 by 5. So 2 by 5 is here, 3 by 5 is there, 5 and 5 will get cancelled, 2 1 2 7 and then I'm getting 3 by 35, which is nothing but calculator. If I'm actually getting 3 divided by 35, it's nothing but 0.0857. So here I will write it down again. Probability of yes given sunny comma hot, which is my independent feature, is nothing but 0.031, and this is probability of no given sunny comma hot is 0.085. Now we'll try to normalize this. 0.085 plus divided by 0.031 plus 0.085. Open your calculator. So if you open a calculator, it is nothing but 0.085 plus 0.031. It is 0.116. So 0.085 divided by 0.116. So it's nothing but 73.73. This is nothing but 73%. And here I can basically say 1 minus 0.73, which is my 0.27, which is nothing but 27%. So if the input comes as sunny and hot, if the weather is sunny and hot, what will the person do? Whether he will play or not? The answer is no. So this answer is no. ये हरा पेन था cleaned, right? Solve the problem, guys. I solve the problem. Okay. Clear? Now try to solve another problem. Pen नहीं खराब करना है, ठीक है? Okay, now my next question will be that if your new data is mild and overcast, if your new data is mild, let's say overcast and mild, now tell me what will be the probability using naive Bayes. Using naive Bayes. This will be an assignment to you all. कर दो यार. Denominator is a constant. Now you can add any number of features. Let's say that I will say that, okay, let's say that I will probably say we can consider humidity and wind also. You basically create this kind of table to find it out. But this will be an assignment. Just do it. Overcast and mild. If it is with respect to naive Bayes, try to solve it. Okay. So how was the session, guys? How was the session? Hit like. Okay. I hope everybody liked the session. Everybody was able to understand naive Bayes. KNN भी खत्म कर दे everyone. KNN भी खत्म कर दे. KNN. Yeah, PDF will be uploaded in the community session. Don't worry. KNN कर दे KNN. KNN कर दे. Shall we finish KNN? KNN is a small algorithm. It will not take much time. See why I am saying denominator is same, because for this also we are dividing by the same number. For this also we are dividing by the same number. So this will be constant. If you want to divide it, divide it. Okay, let's finish off KNN, because again tomorrow I'll plan for something else. No, tomorrow we'll do SVM and all. So the second algorithm that we are going to discuss about is something called as KNN algorithm. KNN algorithm is a very simple problem statement, okay, which can be used to solve both classification and regression problem. Are 15 minutes, guys, 15 minutes. This will also get over. This will also get over. Just 15 minutes. Okay. So KNN basically means K nearest neighbor. K nearest neighbor. Let's first of all discuss about classification problem. Number one, classification problem. Let's say that I have a binary classification problem which looks like this. I have two data points like this one, and this is another one. Okay. Suppose a new data point which comes over here, then how do I say that whether this belongs to this category or whether it belongs to this category? If I probably create a logistic regression, I may divide a line. But in this particular scenario, how do we define or how do we come to a conclusion that whether this will belong to this category or this category? So for here, we basically use something called as K nearest neighbor. Let's say that I say that my K value is 5. Okay. So what it is going to do, it is going to basically take the 5 nearest closest point. Let's say from this you have 2 nearest closest point, and from here you have 3 nearest closest point. Okay, so here we basically see from the distance that which is my nearest point. Now in this particular case, you see that maximum number of points are from red categories. From red categories, I'm getting 3 points, and from white categories, I'm getting 2 points. 2 points. Okay, now in this particular scenario, maximum number of categories from where it is coming, we basically categorize that into that particular class. Okay, that is what k nearest neighbor is. Very simple. Just with the help of distance. Which all distance we specifically use? We use two distance. One is Euclidean distance, and the other one is something called as Manhattan distance. Okay, so Euclidean and Manhattan distance. Rajan, you can go. See, don't worry if your mess is closed. Just go and have your food. This you can probably see it after class also. Okay, so two distances specifically used. One is Euclidean distance and the other one is Manhattan distance. Okay, Manhattan distance. Now what does Euclidean distance basically say? Suppose if this is your 2 points, which is denoted by x1 y1, x2 y2. Euclidean distance, in order to calculate, we apply a formula which looks like this: x2 minus x1 whole square plus y2 minus y1 whole square. Okay, whereas in the case of Manhattan distance, suppose these are my 2 points, then we calculate the distance in this way. We calculate the distance from here, then here. Right, this is the distance we calculate. We don't calculate the hypotenuse distance. Okay, so this is the basic difference between Euclidean and Manhattan distance. Okay, now you may be thinking, Krish, then fine, that is for classification problem. For regression, what do we do? See, for regression, what do we do? For regression also, it is very much simple. Suppose I have all the data points which looks like this. Okay, now for a new data point like this, if I want to calculate, then how do I calculate? Then we basically take up the nearest 5 points. Let's say my k is 5. K is a hyperparameter which we play. K is a hyperparameter. Okay, now suppose let's say that k, it finds the nearest point over here, 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 here and here. So if we need to find out the point for this particular output with respect to the k is equal to 5, it will try to calculate the average of all the points. Once it calculates the average of all the points, that becomes your output. Okay, so regression and classification, that is the only difference. Okay, so probably in the next class I will try to show you practically how to implement this, because this k is actually an hyperparameter. We try with k is equal to 1 to 50, and then we probably try to check the error rate, and if the error rate is less, then only we select the model. Okay, so this is regarding the k nearest neighbor. Okay, now two more things with respect to k nearest neighbor. K nearest neighbor works very bad with respect to two things. One is outliers and one is imbalanced data set. Now if I have an outlier, let's say I have an outlier over here. This is one of my categories like this, and this is my another category. Let's consider that I have some outliers which looks like this. Now if I'm trying to find out the point for this, you can see that the nearest point is basically blue only, and it belongs to the blue category. But because this is outlier, it will consider that the nearest neighbor is this. So then this will be basically treated in this group only. Okay. For regression, how do you know what value? Diksha, we are just talking. See, when I'm talking about this point, I'm talking about this as an independent feature, not dependent feature. This independent feature will be nearer to this independent features, right? I'm nowhere talking about dependent features here. Okay. Suppose this is my feature 1, feature 2. It gets plotted somewhere, right? Okay. Formula for Manhattan distance, it uses modulus x2 minus x1 plus y2 minus y1. Modulus. Mode. So not modulus, mode. x2 minus x1, y2 minus y1. Okay, guys. So I hope you like this session. How many of you like this session? And see, that is the reason why I like this theoretical things a lot, because you will be able to understand all these things properly. Okay. So I hope you like this session. This again will be given to you, everybody. Please make sure that you join the community session. So this is basically my machine learning community third session, right? So this was it from my side. Have a great day ahead. And this all materials will be available to you along with the file that I have actually created with respect to the code. Then make sure that you make 1000 likes. 1000 likes have not been completed today. I know some people, how much I teach, they'll not like my explanation, but can't help. I can't satisfy everyone. Okay. Nobody can satisfy everyone. Okay. So, yes. This was it from my side, guys. And yes, I've also made detailed videos about whatever topics we have discussed today. You can directly go and search for that particular topic. And yeah, this was it. I'll see you. Have a great day, guys. Bye bye. Keep on rocking, keep on learning. Never give up. Hit like and then leave and sleep aram se. And